Hi everyone, myself Dr. Lakshmi Prasad, working as an Associate Professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the different types of data presentation. So already I covered some of the topics in previous video. Now I'm going to see what are the different types of graphs that are available for presenting the data. So very first thing, what should be a graph? So it is nothing but the two-dimensional drawing showing a relationship between two of set of number by means of a line or maybe a curve or series of bars or other symbols. So typically an independent variable is represented on horizontal axis and the dependent variable is going to be represented on vertical line, what we called as y-axis, and the perpendicular axis that should be intersect at a point what we called as origin. And through the graph should normally going to have four types of quadrants representing the positive and negative values of the variable, and usually only the northeast quadrant is shown and negative values does not exist or of no interest. Okay, so this should be the graph, so which is going to be divided, so many of them know that, and we should be going to have x-axis and y-axis, what we call a horizontal line and vertical line. So the perpendicular axis that should be intersect what we called as the origin, and the graph should be going to have four types of quadrants, positive and negative values, you can able to show it. And so what should be the advantages and disadvantages of the graph should be that. So when it comes to advantages, it should be very attractive and should give bird's eye view of the data, and it should be easily understood by a common man, and it should also facilitate the comparison of various characteristics, and impression is going to be created by them are going to be long lasting, and the theorems and results of statistics can be visualized using graphs. Okay, so the advantage should be, so it should be very attractive one. So by seeing the graph, so the data what we collected from different sources should be a raw data, and if I'm going to show it, then it should be very attractive, and then it should also give that bird's view of the data, and it should be commonly understood by a common man very easily. So not only the educated but the uneducated people can also be understood by seeing the graph what should be it is and what is going to be represented, and it should also facilitate the comparison of various characteristics, and the impression is going to be created by them are going to be long lasting one. And when it comes to theorems and results and statistics, that can be visualized through graphs. And limitations may be that there should be visual aids and can't be understand as alternative for the numerical data, and through theorems and results should be easily visualized by diagrams and graphs, and mathematically rigor cannot be brought in, and more accurate than tables, but only tables can be used for further analysis and can be misread easily, and possibility to create a wrong impression using graphs. So there should be visual aids and cannot considered as alternative for numerical data, and to theorems and results which should be easily visualized by the graphs and diagrams, and it should also be more accurate than tables, but only the tables can be used for further analysis and can be also be misread easily, so it should also be create a wrong impression using the graphs. And the principles, so what kind of principles they have to follow for creating a graph? So instead of representing the data, so we should be able to, so very first thing should be the title of the graph, so it should give information about the diagram, what it is meant for, and the scale. So the selection of scale should be neither too small or neither too large, but also represent the size of the unit. And neatness should also be good and attractive. So different types of lines, shades, colors can be used, and originality should also help the observer to see the details of the accuracy. And simplicity means the good diagram able to depend upon easy with which an observer can interpret it. And economy means the cost and labor should be excited through a diagram. So these are the various principles. So very first thing should be the title should be considered, and next scale. So how much scale? should be going to be used for representing the size of unit, and then attractive means different types of data like lines, shade, colors can be used, and originality should also be considered while seeing the while the observer is going to see the details of accuracy and simplicity. So a good diagram depend upon easy which an observer can interpret an economy like cost and labor should be exercised drawing the diagram. And classification, so normally the data going to be on presentation is going to be classified into different types like graphs and diagrams. When it comes to graphs, so we're going to see that what should be histogram, frequency curve, frequency polygon, okay, line graph like this. And when it comes to diagrams, so the bar diagram and pie diagram, so that should be the two types of diagrams that are available for representing the data. So normally the classification of data representation should be of two types like graphs, and the second one is the diagrams. And the graph should be that histogram is the thing which should be constructed through bar graph. So how the bar graph looks like that in similar fashion, but they're not going to maintain any space between them. And frequency curve can be obtained from the histogram itself, and frequency polygon can also be obtained from the histogram, and only gives is other kind of representing the data presentation. And the line graph already you know that. Similarly, when it comes to diagrams, so the diagrams will be simple bar, multiple bar, component bar, percentage bar, and deviation bar. So like this, we're going to have different types of bar diagram, and pie diagram should be other kind of diagram what we are going to have. So bar graph, so which is going to display the data by using the bars of equal width on the grid, and the bars may be vertical or maybe horizontal. What do you think like graphs are going to be presented? So like if it is a vertical graph, so the lines should be uh, horizontal and vertical. So the bars are going to be presented in particular vertical fashion, where this in one should be presented in horizontal one, where the bars are going to be presented. So and pictogram is another type of graph what we're going to see. We are able to represent pictures and symbol to display the data, so that what can the observer can easily observe this data what is going to be that, and should also be represent more than one object. And he tells that the picture each picture represents here. So instead of representing this data here, so we can able to represent the pictures, so so that what can the observer can able to easily understand by seeing the picture. And next one is that broken line graph. So broken line graph means a graph going to be show the data points, and which is going to be joined by line segment, which is going to be show the trends over the time at the time. Right, so that should be broken line graph. Okay, so normally the line graph going to be used many kind of applications like in cricket or in stock markets, so where this value is going to be changed over the time. So that kind of graph what we call it as the broken line graph here. And this point how this broken line graph will be obtained means, so by taking by seeing this example, I'm taking the days on the x-axis and the number of magazines that is going to be sale in each every day I want to show it. So for that, so what should be this? So I'm going to take Monday, Tuesday, Wednesday, and like this I'm taking. And how many number of magazines that are sale in 20 in Monday I want to show. For that, if it is 20, so mark a point here. And similarly for Tuesday, it should be 25, mark it here. And so for Wednesday, it should be 45. And Thursday, it should be around 50. And if Friday, it should be 15 like this. So once this, then you can able to join all the data through point, all the points through the line, then what we call it as the broken line graph here. And continuous line graph, so like this we're going to have different types of broken line graph and continuous line graph. So here also the same thing, so where I can able to where the points are going to be joined by a line between the plotted points having some meaning. Like, so in x-axis I'm going to take independent one, that is heating time I'm taking, and for dependent I'm taking the water temperature. So if it is the heating time, what should be this a normal water temperature here, and what should be next water temperature, and what should be the next water temperature, next value, and for every 2 minutes, for every 3 minutes, what should be the value, like this. So once this data is obtained, then all the data is going to be joined by a line here. And scatter plots. So scatter plot is another kind of graph what can able to represent the data here, and where we can able to in scatter plot we are going to be shown as all dimensions. We're going to have some values where the horizontal values are going to be shown in vertical values are going to be shown two sides, and there should be one vertical line, and we can able to represent the dots here where the over the plot, and for all the plots lies in its linearly, then it should be high positive correlation. And if suppose if the dots is going to have in different locations of the graph, then it should be not have any kind of relation between them. So these are the some of the different types of graphs here. And so these are the other kind of graph what we're going to show from that should be represented from bar diagram. So this histogram is going to be represented similar fashion by a set of rectangular bars, and these variables are going to be taken along the x-axis on y-axis. And but here we are going to show this class intervals here. So this based on the class intervals only can able to construct the histogram. Whereas in bar diagram, we should not going to maintain the class intervals. So based on the value of the independent variables, we can able to show this bars. So when I'm going not maintain this space, and that too I can able to show this in between the class interval here, then it should be become the histogram. So that is the difference what you are going to have between the histogram and bar diagram. And with all the class interval should be same, like within difference of 2 points or 3 points, like this we can able to show it. And set of bars also obtained what we can able to should be the histogram, and the total area under the rectangle histogram represent the total frequency. And if the frequency distribution have inclusive class interval, then should be converted into exclusivity. So histogram is also be going to be presented by set of rectangular bars, and the variables are going to be shown on x-axis, and the frequency is going to be taken on y-axis. So once the class intervals is defined as the base, so the rectangle with high proportional to the class frequency are going to be drawn, and set of rectangular bars so obtained gives the histogram. And frequency graph, how this should be obtained here. So the variables are going to be taken on x-axis, and frequency is going to be taken on along the y-axis, and the frequencies are going to be plotted against the class mid values, and then these points are going to be joined by a smooth curve. So the curve what we obtain should be called as the frequency curve here, and the total frequency and total area under the frequency represent the total frequency. So the frequency curve show here also the variable are going to be taken, and then the frequency is going to be taken on y-axis here, and these frequencies are plotted against the class values. How the histogram is going to be constructed in similar fashion. So once the histogram is constructed, so all the points of the rectangle ball is going to be joined by a smooth curve. That thing what we call it as the frequency curve, and the curve and the total area under this curve represents the total frequency. So this is the diagram histogram what we have initially right here. So for this, we initially find out the midpoints of each and every rectangle bar what we obtained here. So once all these points is going to be joined by a smooth curve, so the curve what we obtained is called as the frequency. frequency curve. Okay, so this is the uh, way of obtaining the frequency curve. Okay, and next one is the frequency polygon. So here the variables are going to be taken x-axis and frequencies are going to be taken on y-axis, the same thing. And these classes frequencies are going to be plotted against the class mid values, and these midpoints are going to join by a straight line here. So the figure so obtain what we call as the frequency polygon, and the total area under the frequency curve represent the total frequency. So the frequency polygon so is the way. Uh, Here also the variables are going to be taken on x-axis and frequencies are going to be taken on y-axis. And here also can able to take the class intervals in between the difference of 5 or 10 like this. So after that, uh, once that one is time, like the previously how the histogram is constructed, no? So here also the same thing. Uh, so once you identify the mid values of each rectangle bar like this, so these midpoints are going to be joined with a straight line, right? So if the points are going to be joined with a straight line, the curve what we obtain should be frequency curve. Sorry, frequency polygon, right? So if the dots is going to be just smooth hand curve, then it should be frequency curve here. If the points are going to be joined by a straight line, then it should be called as the frequency polygon. So ogives so is the other kind of data representation. So which one able to but we can able to construct this ogive based on the cumulative frequency. So previous one the frequency curve and frequency polygon is going to be constructed from frequency what we call it as the frequency curve or frequency polygon, and ogives is the thing where you can able to represent it from cumulative frequencies. So ogive is the smooth graph with cumulative frequencies plotted against the values of variable, and class limits are going to be taken along the x-axis, and cumulative frequency curve is going to be taken on y-axis. There are two types of ogives, like less than cumulative frequency ogive and greater than cumulative frequency ogive. Okay. So ogive is the smooth graph which is going to be obtained with cumulative frequencies plotted against the values of the variable, and the class limits are going to take on x-axis, and cumulative curve is going to be taken along the y-axis. And there are two types of ogives. So less than cumulative frequency ogive and greater than cumulative frequency ogive. So the class boundaries are going to take on x-axis and cumulative frequency are going to be taken on y-axis. So here also the intervals are going to take. So I'm taking the class boundaries and cumulative frequency is going to take. So the corresponding values are going to be plotted, and this the line joined by a straight line what we call should be as ogive. So what should be this less than cumulative ogive and then greater than cumulative ogive. So less than cumulative frequency ogive means so here the variables are taken x-axis and less than cumulative frequencies are going to take along the y-axis. And this less than cumulative frequencies are going to be plotted against this representative variable values, and these points are going to be joined by a smooth curve, and the resulting graph what we obtain should be considered as the less than cumulative frequency ogive. And similarly, greater than cumulative frequency occur means, so here the variables is going to be taken along the x-axis and greater cumulative frequency is going to be taken along y-axis, and this one is going to be plotted against the respective variable values, and with the points what we obtain, and which is going to be joined by smooth curve, what we call it as greater than cumulative curve. The two ogives are going to be drawn together with a common axis, and the point of intersection of two ogives gives the median point of the distribution. The ogives are going to be used to locate the partition value like median, quartiles, decline, and percentiles. Right? So the two ogives which is going to be drawn on the same common axis, but the point of intersection of two ogives gives what we call it as the median point of the distribution. And this normally these ogives are going to be locate the partition values like median, quartile, declines, and percentile. So see this here. So this is the after plotting these points, and all the lines are going to be joined, and the points which are joined together actually should be presented as blue curve, and similarly another ogive I'm going to be drawn, that should be red color. So the blue color what it should be pointed as less than ogive, and similarly the red curve is going to be represent greater than ogive. Okay, so this both of them once drawn, and the point of intersection of two ogives, right, uh, called as the median of the distribution. Let it be 42. Okay. So once you can able to consider less than ogive and greater than ogive, the point of intersection of two ogives, which is going to be shown, should be treated as the median of the distribution. So how this cumulative frequency is going to be calculated? So let's take factors like rating, frequency, and less than cumulative curve and greater than cumulative curve. So once this variables obtained, so rating I'm going to give it as 0 to 2. With a difference of 2, I'm taking that should be the class interval I defined, and the frequencies already got it from the data. Suppose if this frequency is less than the cumulative frequency, then it should be comes under here. And similarly, if it should be greater than that, then point out to the greater than cumulative. Similarly, like this can able to identify the cumulative frequency which is going to be greater than cumulative frequencies or not, you have to be identified. So once this one is identified, then we are going to be construct this uh, less than cumulative curve and greater than cumulative curve, uh, and which is going to find out the median. So line graph, already I said. So this line graph is going to be obtained through time series graph. So which is going to be compared to variables plotted on x-axis and y-axis, and the x-axis is going to represent the measures of time. So while the y-axis is going to represent the measures of quantity. So the x-axis is going to represent the time here, and the y-axis is going to be measures the percentage. So then we're going to be organize the present data in clear manner, which is going to be show the relationship between the data. So this is the wildlife populations like bears. Blue color is going to represent the bears, and this one is going to represent dolphins, and this one is going to represent the whales. So there should be the wildlife population. I want to show it, and so for every year, how much number of whales, dolphins, and bees, I want to find it out. So by seeing this line graph, we can able to obtain clearly. So the line graph displays the change in direction. So that means that the population of bears is going on increasing by seeing this graph, and dolphins, the population is going to be decreasing by seeing this one, and there should be up and downs here by seeing the population of whales. So I can able to get clear idea by seeing this line graph here. So but it should be based on the time here. So this 2017 how it would be, 2018, 2019, 2020 like this. I can able to based on the time you can able to represent, then it should be called as the time series graph. It shows the trend of the event occurring over a period of time to show whether it is increased or decreased. Right. So that should be the line graph. So these are the some of these presentations of data where you can able to show into uh, different things. So the graph should be a two-dimensional way where you can able to represent x-axis and y-axis, and which is going to show different types of quadrants. And advantage should be very attractive, and which can also gives the bird's eye view of the data, and which can easily understood by a common man, and it should also facilitate the comparison very easily, and the impression is also going to be very long lasting, and theorems or results of statistics can be visualized very clearly. And comes to limitations, so limitation means it cannot be considered altered for human data, and so theorems and results can be easily visualized by diagrams and graph, and more accurate than the tables, but the tables can be used for further analysis. And when coming to the principles, so while drawing the graph, we have to be concentrate what type of things we have to be follow. So first we have to follow the title, scale, neatness, attractive, originality, simplicity, and economy. So these are the principles what we have to be follow while drawing the graphs. So normally the graph presentations will be of different types, like graphs and then diagrams. And again, this graph should be of different types, like histogram is the thing. So from the histogram, we are able to construct frequency graph. From the from the histogram, we are able to construct the frequency polygon, and occurs also going to be constructed from the cumulative frequency. Whereas this thing is going to be distributed from frequency here and the line graph. So while coming to diagrams, so these diagrams will be of different types, like bar diagram and then pie diagram. So again, this bar diagram further divided into simple bar, multiple bar, component bar, percentage bar, like this. So like this, I can able to divide it into different types of bar. So like simple bar means how it will be means it should be going to present in single one. So that should be called as a simple bar. And multiple bar means where for the single attribute like A, I can able to represent the two characteristics. Then it should be called as the multiple bar. And some this component bar means where can able to divide the bar into different components like A and B, and again A and this one is B, and for A and this one is B, like this I can able to show. So this is going to present one part, and this is going to present another part. And similarly, the percentage bar diagram is the thing where you can able to represent this percentage bar. So that means which the bar is the height of the rectangle bar is going to match with 100%. From that, we can able to show the values. Okay, that should be component. So similarly, another type of what we call it as a pie diagram. So the bar graph will be of different types of horizontal and vertical. And pictogram is another kind of graph which is able to show the data in the form of pictures and symbols, so that the observer can easily understood what the data it is and where it is, what is that. And broken line graph, so where the line graph can be obtained through this over the time, and all the points are going to be joined by dotted line here. Okay, sorry for that. Dotted line here. So that should be broken line graph. And similarly, the continuous line graph. So since how the line graph is constructed, so once the dots is going to obtain, then that should be joined by a straight line. That is what we call as a continuous line. And scatter plot is the thing where we're able to take this x-axis and one direction, but I'm going to take this y-axis values on both directions, and we're going to plot the dots on the graph. So if all the points are very close to each other, then it is going to have high positive correlation, and if it is not, then it should be no correlation. So histogram is the thing where we're able to represent based on the class intervals and then relative frequency. So once this histogram is obtained here, so from this histogram, so then finding these midpoints of the histogram, and if the points are going to be joined by smooth hand curve, then it should be called as the frequency curve here. And suppose if the dots are going to be joined by a straight line, then it should be called as the frequency polygon. So these are the things that have to be identified. So frequency curve, and this should be the frequency polygon. And OQ is the other kind of graph which is going to be constructed from the cumulative frequency curve. So cumulative frequency curve. So there are different types of OQs also available, like less than cumulative curve frequency OQ and for greater frequency OQ. So less than cumulative frequency OQ and then greater than cumulative OQ means. So here the only difference is that so the plotted points are going to be joined by smooth curve, and here the value the greater values are going to be taken on the y-axis and less cumulative frequency going to be taken on y-axis here. So that is the only difference between the less than OQ and then greater than OQ. And so once we obtain this less than OQ curve and greater than OQ curve, so there should be a point of intersection definitely may occur. Then that things is going to be median point of the distribution. And the OQs are going to be used to locate the partition values like median, quartiles, declines, and percentile. So like this, so this is the one less than OQ curve and this is the greater than OQ curve. So the point of intersection of both the things what we call it as the median of the distribution, and this thing is going to obtain from this cumulative frequency table. And line graph is the thing which is going to be obtained by through time series of data. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.